Well, how many of you are, because I mean a good number of you, well some of you were already here, how many of you are familiar with and have used threads in actual applications? Threading, concurrency, okay. I'm going to go ahead and start with the beginning stuff anyway. It just won't take more than 10 minutes. But that's fine. I added one slide.
You have slides.
I do have slides. I have slides.
It's mandated by Uncle Bob.
No, it's not. In fact, he's perfectly happy with not having slides. For context, I've stolen some slides out of a 3-day course that's about 75 to 80% sitting in a computer coding, using tests and substance to work through things like deadlock and live block and all that kind of stuff.
2 minutes in and tests have been mentioned. 2 minutes in and tests have been mentioned.
But I tried to avoid talking about TDD last time because we've had too much test done on our jobs.
Stop talking about your joke.
My jokes are rather pleasant.
The camera didn't see you.
Oh God, he's got the camera right on me. Are we recording?
The Apple police are going to come and take your Mac away from you because you're using PowerPoint.
It's even worse. I'm using PowerPoint in parallel with XP.
You have to use Keynote.
I could get Keynote. The problem is I still haven't been convinced that other tool that you showed me is a really good replacement for Visio. I can express my drawings so much faster in Visio. So I've got Visio. And
just because you're used to it.
Well, no, I 100% agree with you. It's just because I'm used to it, and I haven't taken the time to unlearn and relearn.
That one's not from Apple itself, though. So you can choose whether or not to use that one. If you have a Mac and you don't use Keynote, Steve Jobs is going to come and get it.
I'd like to see him try. He's more of a dork than I am.
You can hire an engine.
I was. Or Keynote. Just use OpenOffice at 1%.
Okay. Any questions before I start?
Do I?
Okay, cut. This is where we'll really start. Take one. Okay, now we got the trailer thing. All right, I'm going to start with some very simple examples. If you want to actually see these, I've got some tests that represent this code, but this is just to make get everybody on the same footing. So here's your first example of creating a thread. You can subclass the class thread, write a run method, and then you can create it. Now this doesn't actually start a thread, it just creates it, and then at some point you can start it later on. Something I didn't mention at lunchtime, and maybe, I don't know how many of you know this, but threads are special. How are threads special? Besides the fact that you get potential concurrency and all that kind of stuff, there's something really important about threads that's not the case with most other objects. I'll give you a hint. After you've actually scheduled them, so that once you set start to a thread, which I'll show you in a second, they become special. And I'll give you another hint. If they're not a daemon thread, they become really special. They're root level objects. Now what does that mean? If a thread refers to something, so long as a thread is running, because a thread will never be garbage collected, the object that the thread refers to will also not be garbage collected. So once you put a thread, I mean, at this point, if this was the end of my method, nothing special about that thread. But as soon as I say a thread.start, it gets put somewhere else. It gets put into a queue of potential threads that could be executed, and now it's a root level object. So long as that object exists, even if it's never run, that object will never go away, and that's actually a big source of potential garbage collection issues. You put something in a thread, you think the thread's going to get cleaned up, you don't clean it up. The framework that you're working in or the container that you're working in doesn't clean it up, and so you end up having crap around in memory. So it's a so-called memory leak. All right? So threads are special to root level objects. This creates a thread. Now, anybody here, is this how you normally create a thread?
No.
Okay. Right. Why not?
If you implement runnable, you can extend other classes.
If I implement runnable, I can extend other classes. There's better reasons than that.
All right.
But that's a traditional reason. Yeah. I mean, how often have you actually had a? Hang on for a second. How often have you actually had a need to extend a class as well as runnable?
Never.
Never. Okay, so that's not a good reason. What do you got?
I just want to tell you.
This is a type actually. So this is thread itself,
Right.
rather than you have a implementation of the runnable.
Okay. I buy that, but it's again that's sort of the same argument. It's a type. I only have one super type. Yeah.
You can't thread pool this one.
Can't thread pool. Well, there you go. That's a good point. If I'm using a framework that uses thread pools, this isn't very thread poolable.
You have to do it
Right?
yourself somehow.
Yeah, it turns out you could, actually, because it implements runnable. And so if thread pools can, right?
Right.
But realistically, threads are root level objects, right? They're heavyweight. You have thread locals. Actually, thread locals are stored via thread. So there's a certain amount of overhead with being a thread. And realistically, going forward, especially with Java 5 and on, there's no reason for you to create your own threads anymore. And you'll see an example why later on. So really, the best reason is it's heavyweight. It's overkill. It precludes really sort of use. I mean, it goes against the grain of using it in a framework, though it would work. However, there is an example. I'll give you an example of where you would want to override thread. If you want to change the default response to being interrupted, then this is where you can do it. Because thread has the interrupt method. And if you want to somehow introduce a common policy, then you might use your own thread. You wouldn't do that most of the time.
If you wanted to do something in the start method, that was weird.
Sure. But do you have any idea what the start method does? I bet you there's some native code somewhere in the start method. They're called by the start method. Okay, now this is the more traditional approach. I'm going to implement runnable, and then I'm going to create a runnable and give it to a thread. All right, any questions about that? And notice I got that comment here. You might want to do something with interrupt. Threads heavyweight, so on. So right here, these two things give you almost concurrency in Java, as opposed to parallelism. What's the difference between concurrency and parallelism? What's parallelism?
That's when you run PowerPoint under parallelism.
Not so much. Parallelism, technically, is when two things are happening simultaneously. So if I have a dual core or quad core machine, I might be actually doing things at the same time. And if my I am doing things at the same time. I mean, I've got the idle process running, and I'm running PowerPoint, and they're running at the same time. My two cores are not doing very much, but they are, right? An example, I just recently, that movie I showed at the beginning, right? I was using a tool to rip it and then another tool to convert it, and both my CPUs were almost pegged out at 95%. I put a little fan on the USB port and kept my Mac running cool because I didn't want it to melt down. Right? That's an example of parallelism. In Java, typically we want to increase concurrency. Now, concurrency is you've got so much time. If I do some operation and then I block an I/O, my program probably isn't going to do anything in this single-threaded environment. So there's going to be this time where I'm waiting that nothing happens. Concurrency is filling in those gaps and using more of the time that you've been given from the operating system to actually do some kind of computation.
So parallelism is really just a special case of concurrency.
I don't know. I would think it's the other way around, actually, if anything.
The other way around?
Honestly, I don't know, Jason.
But you can achieve parallelism through the concurrency if the underlying architecture supports it.
You can achieve concurrency through parallelism, but you can't achieve parallelism through concurrency. However, in most cases, here are the reasons why you might want to use concurrency and or parallelism. The primary reason is probably to increase throughput of your system or responsiveness. So I might use threads so that my system appears more responsive. Or I want to increase the performance of the system. So normally it's for a non-functional requirement. Okay. With parallelism, there are certain algorithms that have been researched that tend to lead themselves through parallel solutions. Genome analysis, I'm guessing. Any kind of cellular analysis, finite element analysis, those kind of things. And the algorithms and the research in the community typically, I think, has been done on machines like Cindy machine and Mindy machines, multiple instruction, single data. Multiple instruction, multiple data machines. And so a lot of the experience is on parallel algorithms. So there are certain algorithms that have been written and have most experience leading themselves to a parallel solution. So I would think that parallelism is the superset, or is the more complex thing, and concurrency is just the lower thing. And Brian, you brought up a good point. If your JVM doesn't support it, then you're not going to get parallelism.
But you can get it if the JVM supports it and you're on a multi-core or multi-processor machine.
Sure,
right?
you could get parallelism. Right. However, your interface to it would always only be through threads, and those threads may or may not be running simultaneously.
Right. That's why I tended toward it's a special case of.
I'll buy that. In that interpretation, I'll buy that, sure. All right. Now, just FYI, here is sort of it all in one big thing using an anonymous interclass. All right. How many of you love Anonymous in their classes?
I'll admit
I
it.
do, but
Well, I like them, but I'd rather have block closures. But that's for another discussion. All right. Now, you guys may or may not know this, but you probably do. You want to call start. What's the difference between start and the run method? Start does
make the run method start.
starts indirectly.
Start schedules the thread to run later.
Oh.
Yeah, start actually changes the state of the thread to available. And then at some point, the operating system will make that thread run. And it'll be in an active state as opposed to an available to run, or I don't remember the names of the states. So if I want to call run, that's blocking, right?
Yeah.
Run is going to call the run method until it returns and pop your way out. Now, if you're using tests, it might very well be that you want to test the run method, and it's okay to call run. That would be an example where you go against the common wisdom, do not call run. But normally you're going to do this, thread.start.
If you go back to the previous slide for a minute,
Previous
why
slide.
would you ever do that instead of just, isn't that exactly the same, isn't that functionally the same as just making your own subclass of thread?
Well, this is where I'm doing my work, new runnable blah. And you always have to create a thread, either because you subclass thread or because you're...
Could you do an anonymous subclass of thread instead of doing that?
Yes, absolutely. And you know what you would do? New thread, open, close parentheses, get rid of the new runnable, and that's
Same
it.
thing.
Yeah. Except you're subclassing thread instead of subclassing runnable, but it would work. Nothing wrong with that at all.
Okay.
All right. Now, just a couple of observations. This is for future. Run can't return anything, and it can't handle any check exceptions. And that's sort of important.
But if you have it anonymously entered in your class, though, it can't access instance variables.
The only way it can communicate outward is by setting some kind of variable that it has access to that's outside these options. All right. So, for example, it could refer to a final local and maybe send it a message. It could refer to an attribute of the class. It could call a method on the class. But the communication is not very direct. It's certainly not there.
No,
Right?
it's not obvious.
But it's what you would do. So this last thing, and this sort of does the whole picture. I start it, and then if I want to wait for it to run, to finish, I'll do a join. Now, if you're doing any kind of timing tests, and you want to make sure that your test runs within a certain amount of time, I don't know if you know this, but JUnit 4 has at test, open paren, expected equals, and you can give it a number of milliseconds. And if the test runs longer than that, it'll fail because it took too long to run, which is pretty handy when you're trying to look for a deadlock. I don't want my test to run an infinite amount of time to figure out I got deadlock. Right? And so what you can do is you can do something like that, but you have to make sure that you join the thread, because I start a bunch of threads up. My test exits. My JVM isn't done, but my test exits. When does the JVM terminate?
When all non-daemon threads are finished.
When all non-daemon threads finish, or if you call systems.exit.
Yeah, daemon threads will just get killed.
Okay, daemon, yeah, that's right. So, but technically, if a JVM is running and the only thing running are daemon threads, and a daemon thread is a thread that has a daemon flag set, then the JVM will shut down. The main thread by default, and any thread that you create by default, if you don't do anything special, is a non-daemon thread. You have to do something special. I don't know, can you do a set daemon afterwards? I think you can do a set daemon on the thread before it started.
Before you start it, yeah.
Yeah, but after you start it, that's all she wrote. But honestly, I don't use daemon threads, so I'd have to look it up. I'd have to actually use the Java docs. All right. Now, you guys have already seen, some of you guys have already seen this, but let's go ahead and go through this real quick. All right, now just a couple of hints for testing. All right, when you're testing, you probably want to run. Now, when you're testing for things like, do I have shared data access problems, or deadlock, or live lock, or starvation issues, you probably want to run with at least as many threads, or maybe one more thread than the number of cores you have. Let me give you an example. I was a while back teaching a boot camp at Hertz, and these two guys were in it. But this didn't happen when you were there. It was during the first week. It was during the Java class or something like that. Now, traditionally, if you write a while loop, and the while loop you accidentally put a semicolon after the while loop, and the while loop never terminates, what happens to your CPU? Pegs in a single core system. What happens if you do the same thing in a dual core system?
One of them pegs?
Or depending, if you look at if you just have a monitor that shows you sort of a blended average, it pegs 50%. So someone had written that code, and I saw it pegging at 50%. Well, obviously you haven't done anything wrong with your code. There's something going on with the environment or something like that. So, just FYI, if you peg one of your CPUs, or your blended average is 100% of 50 or 100% of 25, if you got a quad-core system, that's probably an indication you got something wrong. But generally, you want to run with more threads than processors. You're never going to actually have that many more threads running, but just so that you're sort of going for context switches and so on. Also, you can throw in thread.yield at random to mix things up. I mentioned this at lunchtime. I'll say it again here. For those of you who are at lunchtime, don't answer this question. Does Java, in its threading model, according to the specification, define threads as preemptive? That is, they're guaranteed at some point to be interrupted, and another one is able to switch in and take over. No, they're not, actually, it turns out. So if you're using Windows 95, Windows 98, and I think Ryan or someone mentioned phone JVMs and such, it's very likely that if you run a thread, if you create a thread that doesn't return for seconds, then that thing, once started, will not be yielded or give up control until it completes. Most operating systems have preemptive threads. BSD, Unix, certainly all varieties of Unix pretty much. Well, all modern varieties of Unix. I don't know about older varieties.
At lunch I sort of thought NetBSD might not.
Who knows?
Because it's like for little devices.
Okay, it might not. And embedded and small devices, and in fact, anything you run the JME on, you'd have to look at the specification. But things like NT 4.0, NT 3, and everything from NT on the Windows side, and certainly Mac, and most varieties of Unix, support preemptive threading. I bring that up because thread.yield is a way for you to say, at this point, maybe I'm about ready to do something computationally intense. If someone else is waiting, go ahead and take it for a while, and then I'll start my computationally intensive thing. It's when you're trying to look for a defective algorithm, throwing in random thread.yields is a good way to, one, make your code run slower, because you cause context switches, and two, it also gives you the, at least in my experience, if you're not finding deadlock and you think there's deadlock, or you're not finding synchronization problems, it's a way to mix things up enough that you can actually experience problems. It's hard to prove that your program is correct in a multi-threaded environment. It's easier, though not a lot easier, to show that it's in a failure mode. Really what you have to do is you have to know what to avoid and then just code carefully. But you can, through testing, improve your chances of finding stuff. One way to do it is put in thread.yield. And just an FYI, when you're doing performance testing, like with threads and with or without threads, you want to warm up your JVM. Why is that? Well, what do I mean by that? Just-in-time compiling. Right, just-in-time compiling. What little I've explored 1.6 goes to just-in-time compile stuff a lot faster. But the effect is the same. We have someone, and do I just hit the exit button?
Hold it down until they open the door.
Come on in.
There you go. He couldn't hear you. I think if you pick up anything at the phone, that'll stop.
Okay. We're getting this right for YouTube.
So what's the server option?
Oh, it turns out that the JVM is very different for the server configuration than the client configuration. Specifically, it's a lot more aggressive about unwinding loops and taking variables out of loops that don't change. And so, if you have a potential synchronization problem, you probably should run it closer to the kind of environment you're going to run. So, if I'm running in Eclipse, and by default, I think it probably uses the client configuration. I don't know if it does or doesn't. It might be harder to discover problems. So, you might want to just put the -server option on your VM when you're executing.
From what I understand, and this may have changed, but I believe the Sun JVM always treats Windows as a client.
Even with the -server option?
I think so. I could be wrong in that, but I think that's right.
Okay.
And also, do what?
We should all use a Mac.
Exactly, or Linux. Get that in there. Also, the server has slower startup time, but is optimized for runtime, whereas the client is optimized for faster startup. Why they can't do both at the same time, I don't know.
Yeah, and well, actually, the 1.6 things tend to start faster because it's a lot more aggressive with lazy loading. And also, you can, I believe once it's loaded, it'll sort of do a snapshot of a lot of the classes loaded, so the next time it starts up, stuff that's already been brought into the environment, it can remember. Yeah. I haven't messed with that stuff at all, but
I've just heard discussions.
you know. Okay, so let's look at an example. And by the way, at any point, if you're not convinced, I can switch over to an Eclipse workspace. And all this code that I've got is in an Eclipse workspace. Or you can just take me at face value. I won't consciously lie to you. Is that Forrest? Looks like Forrest, huh?
Wow.
Okay, so here's an example. The top class is the thing that has my data. All right, I have increment value and get value, plus value, return value. Nothing special there. And down here, I've got something that actually increments the value. It's a runnable, and the idea is if I create one of these, in the end, that value will get incremented 100,000 times. Is that 10,000?
Yeah.
10,000 times. But if I did 10 threads, it'd be 100,000. 8, give or take. Any questions about this combination of code so far? In a single thread, this works fine. What happens if you share that top object, one instance of that top object with multiple threads? What can happen?
It'll reset all over the place.
Now it won't reset.
We context switch after value is retrieved before it is incremented.
How many operations, and Jason, you can't answer this, and anyone who's at lunchtime should answer this. How many operations is plus value? Yeah, Brian, you know. 3. Read the value, update the value, store the value. It turns out that it's a non-atomic operation. And the important thing about the non-atomic is it could be interrupted right before the first operation, after the first operation, before the second operation, after the second operation, before the third, or after the final one. So that's not safe code. This is not multi-thread safe.
So increment could either increment it twice or not at all.
Yeah, actually, well, it could go either. It could go. Most likely, you'd end up losing an increment.
Yeah.
Right? Because I read a value and then I'm about ready to set it to one more. Someone else does it in front of me, and then the work I just did gets overridden because they. Yeah. But that's the more threads you have, who knows what can happen.
Yeah.
It could jump back. It could jump forward. I'm not exactly sure. I'd have to think about it. But the bottom line is, this code is broken in multiple threads. Now, this is we're still in the basic threading stuff. So what's the solution to this? And again, synchronize, yeah. If you're at lunchtime, well, you can answer if you want. All right. So here's a couple of tests we can use. And by the way, the first one creates one thread to make sure it works, though who knows if it actually does or doesn't. You'd have to run this a bunch of times, I suppose. Down here, I create 5 threads. I create 5 threads here. I start them all, I join them all, and then I print out the result. And hopefully I shouldn't use assert equals. I've updated the code. I haven't updated the slide. Hopefully the value is the expected value. It turns out that if you run this, it will fail occasionally. The frequency with which it fails completely depends upon the operating system, in my experience, because different operating systems, different JVMs, different thread scheduling policies, and all that kind of stuff.
Could you, I know you said, I'm going to skip to something you said at lunch, is that you don't use thread priority. But could you make this happen more by putting like 1,000 other sleep threads out there that are at regular priority and making these 5 at low priority to force context switches to happen more often?
Possibly. But the thing is, Java only, I think, supports 5 levels. And then how those map to the underlying operating system, who knows? Who knows? But it is possible to get these to fail. But I effectively have 3 operating systems on this because I could use Mac OS, I can use Parallels, which is a virtualization of XP, or I can use Boot Camp and actually run XP native. And I get 3 different characteristics. Because Parallels doesn't see I don't think Parallels sees the dual core. I'm not sure about that. It sees it as a single core processor. So, with that in mind, isn't Java write once, run anywhere? Turns out it is. There are guarantees, and there's a memory model that defines the semantics. This is actually a pretty easy to solve problem. There's the solution, and someone already pointed that out. What does synchronize do?
Forces one operation to finish with the next start.
It makes it, yeah, basically it puts a lock on the current object, which in this case would be an instance of increment value. So it's like synchronizing on the this, right? And what that means is, if I have n threads, only one will ever be executing that particular method. Now, it says nothing about the other threads, or other methods in that object. But that particular method, if it's the only one that's synchronized, it's guaranteed that that method will only have one thread going through it at once, which makes the whole operation, which looks like one line, atomic.
I'm going to show how much I don't remember from my certification studies, but if I recall correctly, I think they said if you have two synchronized methods in a class, and you call one synchronized method, someone else tries to call the other synchronized method, the object it's synchronizing on is this, isn't it? So the other method will block until that first method finishes.
Correct. So synchronized, all the methods on a class that are synchronized are guaranteed to only be executing by one thread for a given instance.
So the granularity is really coarse on that.
And let me say that again. If I have one instance of this increment value object, sorry, of the underlying object, which this is object with value, yeah, then at most I can have one thread. But if I have 1,000 instances, synchronize only says about the current object this, all right? And by the way, how does this method know the current object?
Because it's
Passed in like a parameter, right? When you call a function in Java, the 0th parameter is the reference to the object you're sending a message to. Send on the activation record. I'm trying to throw in some different low-level details, just try to mix it up a little bit from today's lunchtime. So when you call a function, a method, an activation record gets created on the stack. The very first thing on the stack is this, and then other parameters. I don't remember the order in which it sends the parameters, but it puts them there. And then all local variables go there as well. If you call the same method again, another activation record gets put on there. This is copied again and again and again. And that's how you implement recursion in a language. And if you've ever had to deal with that, in my assembly class 20 some odd years ago, we had to implement recursive algorithms in assembly, and we just used activation records. It's actually really simple. But pretty much all modern languages like Java, C++, they all do this kind of thing. Right? Even languages like Ruby do this kind of thing. So, in Smalltalk, activation records are first-class objects, and they're garbage collected like first-class objects. So that's a little trivia. It's an interesting thing. They fixed that in 1978, and that's why they don't have to worry about this final crap on variables with the anonymous inner classes. All right. So there's a lock. Every object has what we'll call the intrinsic lock. How many of you have heard of semaphores? All right. For those of you who have heard of semaphores, this is a binary semaphore. It's a semaphore with an initial value of 1. When someone tries to get the lock, the count goes down to 0. When someone else tries to get the lock, they wait. The count goes to -1, -2, whatever. And then when someone, I don't know what the negative value is. When someone releases it, it goes back up to 1, and one of the people that's waiting goes ahead and gets it. And for those of you who know what this means, it's not fair. So if I have 10 threads, it's not first come, first serve. It's who knows who's going to go first. All right? Questions about that?
Talk about copies of the object, the value object in your previous slide.
So copies of this one?
Yeah, thread local copies.
Okay, so thread local copies. All right, thread local. Okay, so how many of you have heard of thread locals? Wow, good number. How many of you have actually used thread locals? All right, now how many of you know that thread locals are really evil? Okay, yeah, you probably shouldn't use thread locals, but that's a whole other side discussion. Thread locals are stored with the current thread. However, what's stored in a thread local? A thread local is effectively a hash map, right? In fact, it is a hash map. It's a key value pair. The thread local class, you can say it's a thread local of a string, for example, and holds a single value, but it can also. But you can think of it as it's holding on to it's a reference container. If I put something in a thread local, that reference can be shared. There's nothing saying it can't be shared. However, with a thread local, typically what happens is you put it in a place that's easy to access, like a static variable. And then everyone tries to access the thread local. And what happens, you talk to the thread local, you say get. Well, all that does is it goes to the current thread and pulls out of the current thread, that's part of the reason threads are heavyweight, the value that you're trying to get, and it returns it back. So effectively it gives you a global variable for threads. Now, One of the reasons why, first of all, I like thread locals. So they're terrible. They're hideous things. They're about as bad. Actually, they're probably worse than singletons, actually, because they're like the singleton that you think is safe, but it's not. If you're using any kind of container and you don't have control over the threads, you're crazy not to. You're crazy to use thread locals. Now, it turns out something like the EJB specification is safe because you know that once the thread starts, it's going to stay there, or is it? What if you have a local object, but you send it through a remote reference? All bets are off if your thread locals are good or not. Now, I'm not. What's your question about thread locals?
Well, it's more about preventing, not about using.
Oh, preventing.
With multi-threaded apps, I've had the same object will have different copies
Right.
of a property in there. And you can force it using the volatile keyword to go to main memory, I believe is what they call it in the spec. Does the synchronized keyword force that value to main memory?
Okay, so let's talk
So
about
if
visibility.
I access that value outside of that method, is it a copy or is it?
Okay, so I was totally in a different place. So let's talk about the volatile keyword. I didn't talk about this much. How many of you have used the volatile keyword? 2 of you. Excellent. The volatile keyword is interesting. So synchronized and volatile are quite related. Synchronized has all the guarantees of volatile, but not the other way around. Yeah, I'm sort of into the new thing. We'll get to volatile, then we'll take a break and you can do your talk, Jason, okay? So volatile, well, actually, let's leave it on that, and we'll go right into volatile versus synchronized and what guarantees they offer. Because there's a semantic meaning to volatile, there's a semantic meaning to synchronized, and it's sort of like a hierarchy. So let's break for